Now, today's session we will discuss about panic. Panic is very important construct in Go. So, as we were discussing, there are three kinds of errors, three kinds of uh, general errors. Normal thing is errors. We know what error does. Error is just a value. Generally, we handle errors with a interface called errors.error. Uh, Error is an interface which returns a string. There is a function, there is a definition called error which returns a string. So errors are just values. That's the first thing. The second thing is panic. Third one is fatal. We're going to discuss about panic. Panic is generally whenever there is an unexpected error happens. Okay. Basically, there is a problem that the program cannot handle things just like an error, but there is something called unexpected thing. That means a normal execution of the program is halted due to some error. Okay, then what happened? The program would unwind the complete stack. I will explain that what I mean to by generally we call it as a panic. So number one, we can call the runtime can call the panic. What do I mean by is, let's say I have a variable number is 0 and then I print line 10 by n. This is a very classic example of panic. This panic is unrecoverable error. Unrecoverable means, yeah, it is recoverable. I will explain it later on. But unexpected. Even though here we knew that we are going to divide by 0, generally we call this kind of things as panic. It's a runtime error basically. So what the runtime error is, divide by 0. Divide by 0 is a very classic runtime error. So what causes the panic? Divide by 0 has caused the panic. So who triggers the panic? The runtime has triggered the panic. Okay, this is called a panic. Basic panic. Fine. Now, this is fine. I'm not going to do this. Let me give this 1. I create an array where array is 3 elements of array. So for I equal to 0, I less than length, I less than or equal to length of array, I plus plus, I say print line array of I. When you run this application, it prints 0 0 0 because zeros are three zeros are the zero value of the array. But the most important thing is we are trying to iterate to the fourth element which is not existed because I give I less than or equal to, which we generally call it as index out of range. This is also panic. Okay, this is a panic. Index out of range is a panic. Okay, the other one. I'm just showing you some panics. How runtime creates a panic. Let me create a pointer. This is pointer. What is the value of the pointer here? The value of the pointer is nil because I have not assigned any address to the pointer. What address does the pointer contain? Nil. I try to dereference the pointer. So this is a pointer. Pointer should contain address. If the pointer doesn't contain address, the default value of the pointer is nil. So basically it's a nil pointer. What we are doing? We are doing nil pointer dereferencing, which is also considered as a runtime error. Panic because you cannot dereference a nil pointer. When there is no address to the pointer, where do you want to keep the value? So this is also a panic. Okay, just a few examples of panic. Three of them you cannot run at once because the moment you uncomment the code, it doesn't reach here and it doesn't reach here. So comment and uncomment and check it. These three are basic panics. So these are all runtime panics. So when you look at panic, runtime panic, that means the panic is caused by the Go runtime. And also there is something we can also panic. You can also panic, customized panic, custom panic, or user defined panic, or trigger panic by the user or developer. You can also trigger a panic. I'll show you. So panic is triggered by the runtime. Here the panic is triggered by the runtime. The second one, we can also trigger the panic. So the most important thing with respect to panic is the call stack. Okay, the most important panic is the call stack. What happened is when there is a panic, let me go and then enable something, write something. Let me go and then write a program. Sorry, I write a function. I write a function and then there got to be the pointers. I iterate through the array over here, maybe a function. Here I raise the panic. So how can I raise the panic? PTR this one, and here write end of main. I may write it here or start of main. So if you really look at it, assume that this is function 1.1, just to give you a name. Here give function 1.1.1 and all. Here also you write print line end of function 1.1. Here also you write whatever you. I just wrote some call stacks. Ensure that there are so many call stacks. So if you really look at it, the program starts here. Array is assigned. Array is created over here. Pointer is created over here. It goes into the anonymous function. It prints hello world, and this is the area where it panics. Okay, this is the area it panics. Let me just stop it over here, put it over here. Okay, this is where it panics. Okay, in which function? Function 1.1.1. So this one, it not only panic this function, but also panics its caller. Its caller, what is who is the caller of 1.1.1? The caller of 1.1.1 is 1.1. Who is the caller of 1.1? Main is the caller of 1.1. If you really look at it, when there is a panic in anywhere, okay, there is a cascading effect. The whole call stack gets crashed basically. I'll tell you what do I mean by. So start of main got printed because here hello world got printed before panic, and the moment it goes to line number 17 there is a panic, segmentation violation error or nil pointer dereference, invalid memory address or nil pointer dereference, that's the error. There is a point panic at line number 17. The moment there is a panic at line number 17, the moment there is a panic at line number 17, it's not only panic this call stack, but also panics everything. That means line number 22 got panicked. I mean this function call. Line number 24 function call got panicked, and even ultimately the main got panicked. So what happened because of this panic? The entire application stack. You can see the stack trace information. This is the stack trace information. Okay, it entire application gets crashed. This is the normal behavior of the panic. We are talking about the panic, which is a system a runtime panic. The panic itself happens at runtime, but the panic is triggered by the runtime due to the segmentation violation error and nil pointer dereference. This is one kind of panic. Okay, this is one kind of panic. I hope you understand. So number one, what is panic? Panic is another kind of error, but it is a more severe error. Panic is kind of a error, unexpected error. So generally the program cannot run. That's what the panic is. So error, normal errors, the program can run by handling the errors. The program can continue to run by handling those errors. Take the error and handle it. Whenever you see panic, the program cannot run, which is called the panic. Generally, what happened whenever there is a panic? The normal execution is halted and the program start unwind the stack, sorry, not the stock, from there onwards. So here the program is halted. It unwinds the stack, so this is stopped and its caller is stopped and its caller is stopped. Ultimately, the program is a runtime error, which we call it as a panic. Okay, exit status code 2. Ultimately, the program is stopped with the exit status 2. You know that other than exit status 0, other than exit status 0, any other exit status is a uh, failed execution of a program. Fine. We have seen that how the runtime panic works. you can also create your own panic. Let's go to this particular program we have created earlier. What we are doing is we are writing a file. We are writing to a file. This is what we are doing. Let me change this program a little bit. Let me create a type file ops maybe, and then I put a file name. I create a new object function new file ops of file name. Okay, just let me create like this. I got file ops. So I create a file ops type structure. I attached a method write to file. Okay, I want to write my own panic here, custom panic. So how can I write my own panic over here? For example, if 5FO is nil, that means the object of file ops is nil. Instead of I return error, I can say panic. It's a panic. So when should you use your own panic? When you identify that, okay, your program cannot run, uh, uh, you can use a panic. Panic should be used. Generally, very sparingly we use panic. We don't use it that regularly. Very sparingly we use panic. When you see that the error that you write, it's pretty critical. It's a critical failure. Okay, and you feel like you don't want to recover from the error. Recover, I'm not talking about recovery mechanism, I'm talking with respect to the context here. That means if the file ops object is nil, then there is no point in even moving ahead with the program. You can create it as a panic. Okay, that means here if I run the application, I create an object. Basically, this is not nil. So what I do, where fo is file ops, this is nil. This is nil. You know that why it is nil. Sorry. So file ops variable is nil. This is your own panic. So you are using a built-in function called panic in order to raise the panic. You see that the program is halted because of panic and it crashed. You can see the stack trace information. This is all the stack trace. At what code the panic, so where which function has caused the panic, what line number the panic happens. You see that clearly line number 24. There is a panic and how it unwind. It has unwind to line number 9 of your program and the entire call stack got crashed. Whatever you run it over here. This is also not executed because your program got crashed. your program got crashed. Okay, this is what actually, let's say one more thing. If f4 dot file name equal to empty, I also panic. So it's not an error. Remember that there is some difference here. I have not put it as an error. There is a subtle difference, not subtle, there is a very big difference. Errors can be handled by returning values and all, but it's a panic. So panic means it crashes your application. Panic crashes your application. Your application would not move further. By default, your application would not be required by default. Okay, it unwinds the call and then it gives you stack trace information where the call has problem, what happened to the call, at what line of the code there is a problem, etc. Okay, now we go to the other part of the panic, other way. So what all we discussed? What is panic? How the panic crashes your application and all. Now there is something that is related to panic and differ. There is something that is related to panic and differ. What panic does is, before going to panic, I purposely give it as a built a function that to tell that there is any number of any, whatever the code that you write that can be executed inside a function. I can directly write print line as well. I can directly write differ print line as well, but I purposely write. You see that actually there is a line number 7. There is a deferred call. You know what the defer is? Defer defers the execution to the end of the calls. And then it goes to line number 10, it goes to line number 11. From line number 11, it goes into the function. Line number 25 itself, there is a panic. So what panic does? Panic halts the execution. That means the execution is halted over here because there is a panic here, exactly. Line number 26. Panic not only halts the execution, it unwinds and then it stops the execution over here. It is panic here. Who is the caller of write to file? Main is the caller of write to file. It not only crashes this function but also crashes main because main is the caller. So as we see earlier, as we have seen earlier, the panics the entire call stack, not only the caller, not only that particular function, even the caller. If there is a caller has another caller, even that caller. Ultimately, it crashes the whole application. But what panic does is, before going to panic, it checks whether there are any deferred functions. Are there any deferred functions? In its call, that means inside the write to file, or even above that, its caller. That means deferred functions could be of anywhere before panic. Before panic, all deferred functions are executed. As I said earlier, try, catch, and final block. Why I said final block is why I can call it as deferred is a little bit similar to final block because Final block is executed in try-catch mechanism even if there is an error. Okay, even there is an error, final block gets executed. Similarly, even though there is a panic, it executes all the defer calls. So what happened? It it executes a defer call. End of function main. Because end of function main is a defer call, so this gets, for example, if there is a defer call over here, this deferred call also gets executed. See, end of write to file function, end of function main. All the defer calls gets executed before going to panic. Before that, okay, if you write a defer call over here and then say that it doesn't execute, this would not be executed. This is after panic, so you don't see that this gets executed. But before panic, that is the relationship between panic and defer. So it could be not only the user-defined panic. If you, it's not only for the custom panic, it's even for the system panic. Whether the panic is by the system or the panic is by the user, so the concept is same. All the defer calls gets executed before the panic. That is the relationship between panic and defer. But what panic does? Panic halts the execution and it crashes the whole call stack, the whole application. That's one of the dangerous part of the panic. Whether it is a panic that is defined by you or the panic that is defined by the system, that is triggered by the system. You trigger the panic or the system triggers the panic, whatever. But the behavior is same. The only thing is they have given you an opportunity, the option, facility to trigger a panic. When do you trigger a panic by yourself? When you feel like that, when you feel like, okay, you cannot proceed with the application due to XYZ errors, you can create a panic. Let's say that you are trying to connect to the database in your application. You tried couple of times, the database connection has not established. Upon trying it for multiple times, the database connection is not established. Then yes, you can call it as a panic because you tried a couple of times. Even then, the database connection is not established. There is no point in moving ahead with the application because database is a very core component. You can call it as a panic. It's not just an error. It's a, calling panic is very sensitive because it's gonna crash your application at least. So you should know that actually calling panic is very rarely, sparingly we call panic, not regularly you call panic, unlike error. Okay, fine. So when there is a panic, the deferred function is executed. All the defer functions gets executed when there is a panic. For example, if I write another defer function, this gets executed, this got executed, and then end of write to function also got executed. When there is a function, when there is a panic, there is a mechanism called recover. Okay, recover. There is a mechanism called recover. Recover is a built-in function. When there is a panic, recover function gets a value. What value it gets? It gets a value regarding panic. When there is a panic, whenever there is a panic, the recover function gets a value. Let me write it in such a way that let me write a function called recover me. If R is recovered or not equal to nil, when there is a panic, the recover function gives a value. So recover, whenever you call a recover function, if there is a panic, the recover function returns the value R. What does R contains? R contains the information about the panic. What information and why there is an information? Because panic is an object. You can pass panic. If you look at the panic built-in function, what can you pass to panic? You can pass any value to panic. It's not just we passed as a string, but technically we can pass any value to panic. Okay. So what is recover? Recover is a built-in function. What recover does? When there is a panic, the recover gets a value about the panic. That means recover gets a value. That means R is not nil. That means R has got some value because R is any empty interface. R gets a value. When does it get the value? Only when there is a panic. But how does the recover knows that there is a panic? So whenever there is a panic, whenever you anticipate that your code may be having a panic, you defer the recover. You defer the recover. What you said, what you do? Generally, your application start here. It goes to write to file, come here, and there is a panic. The moment there is a panic, the moment there is a panic, all the differs are executed. So this is the differ that gets executed first because this is the first one, this is the second one in the stack. So this gets executed first with respect to write to file. What is recover me? It goes to recover me, and recover is R not equal to nil. Yes, R not equal to nil. The reason is there is a panic. If there is no panic, R becomes nil. It does nothing. It comes here. If there is no panic, R is nil and hence does nothing. If there is a panic, R will become not nil, and here we are just printing. We're not doing anything, but generally we are printing. So what recover does? What recover does is recover recovers from the panic because the panic behavior is it halts the entire execution and it crashes the entire code. Entire code gets crashed. Entire application gets crashed. Okay, that effect can be minimized by recovering. Recover says that what recover is there is a panic over here. Let's not execute this call, but do not crash the entire application. Do not crash the entire application. Let's say I'll put it over here. I equal to 1, I less than or equal to 10, 20, I plus plus. For example, I'm going to print some numbers, print line. Okay. Uh, if I modulus 2 equal to 0, okay, print line I. This is called after panic. You see that panic happens here, we are printing over here. So what recover does here? There is a panic here. There is a panic here. If the panic is caught, of course, there is a panic here. Why should I crash the whole application? Rather, let me halt only this part, this caller, only this particular function. But do not destroy the whole application. So stop this execution and then continue from the next part of the execution. This is what the recover does, which we call it as a recover. 0 bytes are successfully written to the file. The reason is there is a panic over here. It comes here. There is no error, but still there is a panic. It came here. 0 bytes are written to the file. I think you have to handle it properly. In fact, this is printing something like this, but it has not crashed the whole application. Rather, it has resumed from the panic. It has resumed from the panic. That's what the most important thing is. That is what the recover. But how does the recover knows that there is a panic? This is a tricky part. Because there is a panic, all deferred calls gets executed. One of the deferred call is recover me. It goes to recover. It's not necessarily that you have to write recover me a function. You can also write a uh, anonymous function. You can write like this as well. Ultimately, it requires something, 2 3 lines of code, which is a function. So the function gets executed. This is what the recover. So the question comes, where should I put the recover? Let me say that here there is a panic. I put a recover. Okay. Maybe here I there might be another panic. Let me say I by 2. Okay, num equal to 0, for example. I by n. Here the panic is recovered, but here there is another panic. What is that panic? Divide by 0. So this recover is not handled by this recover because this recover is already called actually. Already called. When there is a panic over here, the recover is already called. Again there is a panic. The application got crashed because it has found another panic. So where to put recover? The recover has to put wherever you anticipate a panic. Sometimes you may not anticipate panic whenever you are developing an application, but you may anticipate a panic. You may found that there is a chance of a panic once your application is start running. But that is fine. You can go and then correct your code. But putting a recover, just put a recover is not a solution for the panic always. You may have to go and then correct the code. You may have to go and then solve the code why it is raising a panic if it is a runtime panic. Otherwise, you can recover from the panic, but this panic is different, not this panic. So every caller, if you any caller that you anticipate a panic, you have to write a defer function. So this panic also this particular part of the code also panic. Before going to panic, it looks for any recovers to execute. It finds a recover. then this recover is going to print the details of the panic. That's all. We are not doing anything. We are just printing the details and ensure that the whole program has not crashed. Okay. But the program would not execute after this because this is a caller. The program would not execute after this. This would not be executed. The reason is this is called after this. The program would not execute. It stops, it halts there, but it would not crash. If you want to recover anything in specific, then you recover it. The main thing is it would not crash. Okay, this is what about panic, differ, panic, and recover. The three things work together. Of course, differ has many other use cases, particularly panic and recover, they are for the same purpose. If there is a panic, you can recover from the panic. For example, you are running a web server, there is a panic, your web server will be crashed. But you don't want to crash your web server. You don't want to crash your web server. Rather, you recover from the panic and run your web server. Web server means, yeah, any web-based application, RESTful application. Then there is a recover works. There is error. You if there is a panic, yeah, you take the data, maintain the data, log trace information, log information, maintain trace information. If any other metrics are required, store all the metrics information, maybe in a metrics database, time series database. Log information inside the loggers. Trace information to the traces. But do not stop my application, is what exactly you are doing. Do not stop my application. This is what actually the panic work and all. Type that panic sends over here, technically any data type, it's not string. In fact, okay, you can also send a file error. The way how we have written, we have been using earlier. Let's say that if there is a panic, I will write a type called file error. For example, I'm just giving you some example. Okay, maybe code isn't, even then this looks pretty, uh, and then I can put file ops is file ops or a message, for example. Just giving an example again. Generally, these kind of things we use it for errors, not for panics. Panic, you can send the file ops. For example, fire error. So when there is a panic, that means here, what I do is panic of address of file error. I give code, maybe the code is 101. File ops object is nil, and then message I give maybe file ops variable is nil. See this. So this is any. So what is this corresponding recover? This is the corresponding recover. Because when there is a panic, this recover gets executed. You go to recover. Sorry. You go to recover. Yeah, here. R is what? R is any. What do you get to R? If the panic happens over here, you get this as R. So you go switch R dot type case file error. That means I get the error file information. Okay, you can get the value as file error actually. fmt.println v dot code. Okay, maybe panic code. Generally, panic doesn't contain code like error. Still okay. Panic message, panic object. Actually, this is nil, however. So you are, see, if you don't do this, you can also do this for your understanding. I'm just telling you. If you don't want to use this v for your understanding, you generally we did like this v dot star, sorry, r dot. We can type asset it star file error dot message. You can also do like this. Can also assert on or can also use v because of any. That the any is very powerful actually. Wherever you see any, never think that it's just a simple type. You are sending some data. The data here we are just sending some dummy data, but it's very powerful. Panic is going to send any. The any could be of anything. Technically, you can type assert and get that value. See, panic code is 101. Main is this, main is this. Okay. But this panic is only for this panic. Let's say that I take this whole recovery mechanism and put it over here. Okay, let me park this code aside. I write a common panic, a common recover me. Then this R comes over here, it works. But the other panic means there is also a panic over here, somewhere here. This cannot be recovered. That you have to handle differently. So I don't know what panic I get it. What is the value of R I get it. So what I do usually, I print R fmt.print and I get to know whether what kind of data type it's getting. So fmt, sorry, reflect dot type of R. So first I print and check what I'm getting it. Then I put it in the what type. Then I correct my code that I'm writing. 68. Okay, it has recovered from that particular panic. End of file, 0 bytes are end of line. What happened here? Didn't I write recover? There is a panic, and I said recover me. It got recovered in fact. End of file function 0 bytes main. We get R. Actually, two times I'm put over here. That is the problem. This is the file error type. This is error string. You see that. What type? This is called error string. Error string. You see that. So the next time whenever there is a panic happens, the type is called error string. So what I do is I can put another case and handle it. That means case error string. It is from the runtime dot. Okay, this is not cannot be handled. This cannot be called. The reason is runtime dot error string. I cannot handle it because it's a lower case, so it is not a public. What I can do right now is I can only put it as default because that cannot be handled. It's just a string. So fmd.println, uh, just R. That's all I can do because it's a runtime dot error string. Error string. You understand what I'm trying to say? Runtime dot error string. But this is a lower case. Since this is a lower case, I cannot access this. It's internally you can print it, but you cannot access it. However, you just print. So, okay. Integer divided by 0, which is a runtime error. It's an error string, so it comes here and it printed over here. Printing is recover means not only printing, you can do anything. Maybe you would like to log it, etc. But you can use since this is v, wherever you see any is very very powerful. You can pass any kind of data to any. Okay, same recover me can work with multiple panics. Let's say here there is a panic. There is a second panic here. Okay. I give status file code is 102. I give it as invalid file name. Okay, file name is nil. That means I create an object. I create an object. This is not nil, but the file name is not empty. So this time it it calls the other code 102 invalid file name because the panic that was it panicked is line number 72, not this one. So this panic has some difference. There is a difference between these two objects. You see that you got 102. Like that, you can do that. So what I mean to say is any is very powerful. Whenever you are passing any, whenever you are getting any, okay, particularly from the runtime systems, like runtime, Go related things like panic and recover, it's not just a string. Even though I'm explaining examples as a string, it is not just a string. It's gonna give you, it could be an object, it could be a data. Okay, so how you gonna type assert and take the data? How can you know that you have to type assert? You need to know. What I do is I go and print the type and understand that what type it's gonna print. I go to that particular type. Let's say here runtime. Okay, for example, runtime. It takes you to the runtime package basically. Okay, runtime run takes you to the runtime package. Inside the runtime package, there is something called error string, but it's in the lower case, so you cannot get the web object. It's a private object, so you can't do anything. Okay, that is how it is. So any is very powerful. Whenever you get any is very powerful. What I do whenever I have to find any, I just print the type, understand what type it is. I go to that particular type implement. Since it is a type, statically typed, definitely the type should be available in the system. I go to that particular type. I understand the type, why that particular type is, and then I put a switch case and then grab the type and I do type assertion and get the type and get the data of details of that particular type. So this is that important. Okay. Uh, I have modified a little bit once again. I have modified a little bit. The reason I modified is here I was using the file name. Earlier I was using the file name as here, but since it is a method from this FO object, so the file name takes from FO object. So where FO dot file name. Okay, that's how it is. Then when you come back to your code, once again, when you come back to your code, here there is no absolutely no panic. Right now there is no panic. Let me delete this file. Absolutely there is no panic because there are two scenarios where it could be a panic. Number one is file ops is nil. Number two is file name is empty. Neither the file ops nor the file name causes the panic over here. So your code doesn't go for any panic. It just writes text to the log.txt file. So there is no panic. There is a panic if you remove this. Here, yes, there is a panic. The reason is we are using it as a panic. So now you get it. Invalid file name is what the object you get. We are using it as a panic. The reason is the file name is empty. So these are the reasons where there, if there is no panic, yes, there is nothing to call even talk about recover. But here, if there is no panic, you may say that why recovery is not working, why recovery is doing nothing. If there is no panic, the recover object R is nil. When there is no nil, do nothing. I said when there is no panic, R is nil and hence do nothing. Nothing to be done when there is no panic. So no panic, nothing, no worries. If there is a panic, handle it. Recover does nothing when there is no panic. That is how the recovery mechanism has to be written.